Hello class, this is a video tutorial on basic trigonometry part 4. In this video, we'll be looking at calculating missing angles. Calculating missing angles using trigonometry is similar to calculating missing sides as seen in the previous video, but with a special inverse used specifically for missing angles. So in the Casio calculator that is often used in schools, you'll see it on the sine, cos, and tan buttons. Here it is zoomed in. It's those yellow buttons there. Those are sine inverse, cos inverse, and tan inverse. These are specifically used when calculating missing angles. So let's just quickly show some examples here just to demonstrate. So it begins as we normally do with missing sides. So we figure out, is it sine, cos, or tan? So let's write out our saw, ka, toa. You can pause and figure it out yourself. So from the angle, notice how the angle's missing this time. From the angle, it is opposite, so O, and here we have the hypotenuse because it's being pointed to from the 90 degrees. There's only one thing here that uses opposite and hypotenuse, and that is sine. So we place it in the correct ratio, so sine of x, we actually don't need that degree symbol, so sine of x is equal to opposite over hypotenuse, and that there is correctly placed. Now what actually happens is, just as we reverse equations, so if we see a division we multiply, and when we see a multiply we divide, and so on. Because this is sine, what's actually happening is we take the inverse of sine on the left hand side, but we also take the inverse of sine on the right hand side. These two are exact opposites of each other, so they negate one another, which leaves us with x on its own. So we write it as x is equal to sine inverse, so sine inverse of 10.8 over 15.7. And this is what we type into our calculator, this one here. So typing it in, so we press shift first, and then sine, and then we get that inverse sine. It's not sine -1, it's inverse sine. Typing in our fraction, 10.8 over 15.7, closing our brackets like this, and pressing equals. Now depending on what's required of you, you may be asked to round this off to decimal places, so this might become 43.46. Now if you leave this in the decimal place as is shown here, we round it to 2 decimal places, leaving it in decimals will always be in degrees. However, we can convert it to degrees, minutes, and seconds. So we could also write this as x is equal to 43 degrees and rounding to the nearest minute, which would be 28 minutes. We write this to the nearest minute. So depending, sorry, that should be an approximate symbol. Depending on how it's been asked to round, you could round it to the nearest 2 decimal place, which will always be in degrees, or round it to the nearest minute, which is in degrees, minutes, and seconds. In any case, the main focus here is that you've learned how to calculate missing angles using inverse sine. Now that's essentially it. It's identical using sine, cos, and tan. So yeah, you can go ahead and pause the video and try a few examples on your own here. So let's move along. You can pause and give this a go yourself. Let's do the second example. So from the angle, we have the opposite and we have the adjacent, A. So opposite and adjacent, that is tan. So it'll be tan of the angle is equal to opposite divided by the adjacent, and that there is a correctly placed trig ratio. Okay, so from here we take the inverse of tan on both sides. Let's write it like this, don't want to move it around, which cancels out these, which leaves us with y is equal to tan inverse of 7.4 over 10.8. So we're taking the inverse of whatever we place in ratio here. So typing that in, remember, shift tan first, 7.4 over 10.8. Closing the brackets, pressing equals, and for this example, I'll always round it off to the nearest minute. Okay, so it will become y is approximately, because we're rounding it to the nearest minute, 34 degrees and 25 minutes. And that's essentially it. Okay, go ahead and give the next one a go yourself. So figuring out, is it sine, cos, or tan? So from here, let's move this across so we're always reminded. From the angle, we have the opposites. And from the angle, we have the adjacent, which is A. So that's opposites and adjacents. This is once again tan of Z is equal to 20.5 over 23. Taking the inverse of both sides, we get Z is equal to tan inverse 20.5 divided by 23. Rounding this to the nearest minute, we get shift tan of 20.5 divided by 23, closing our brackets and pressing the degrees minutes button, we get 41 degrees and 43 minutes. That's rounding to the nearest minute for this one. Okay, so here we go. You can pause and try this next three yourself. Let's go through this very quickly now. All right, so here we go. I can see from here we have opposite and adjacent again. That is tan. Let me just quickly double check. Did I do that one correctly? Yes, this one is still definitely tan. That's opposite adjacent. So from here, it's tan once again. So tan alpha is equal to, just quickly double checking, because I thought here I had done cos. It's still tan again, so it's tan 3 times in a row. So tan of alpha is 18 over 7.2. Alpha is equal to tan inverse 18 over 7.2. Into our calculator, shift tan inverse of 18 over 7.2. Closing our brackets. And rounding to the nearest minutes, we get alpha is equal to 68 degrees and 12 minutes. Once again, from here we have the angle beta. From here I can see we have the adjacent and the hypotenuse, so that is cos. So cos of beta is adjacent. I'm going to need some space here. So 14.7 divided by 23.4, taking the inverse of both sides, cos inverse of 14.7 divided by 23.4. So beta is approximately, so shift cos of 14.7 over 23.4. Closing our brackets, rounding to the nearest minute. So this is approximately 51 degrees and 5 minutes. And lastly here, from our angle, this is y or gamma. We have opposites and the hypotenuse. So that is sine of gamma is equal to opposites, 334.5 divided by 42.7. Taking the inverse of both sides, sine inverse of 34.5 divided by 42.7. Gamma is equal to, or approximately, into our calculators, shift sine, so sine inverse of 34.5 over 42.7. Rounding to the nearest minute, this gives us 53 degrees, 54 minutes. So, I hope that gave you an insight into calculating missing angles for using trigonometry. I hope to see you in the next video, and best of luck.